So for today, I've given you a study guide over lessons 5.1 and 5.2 that we've been working on. Lesson 5.1 had us working on bisectors of triangles, and the first thing we talked about were perpendicular bisectors. It says a perpendicular bisector is a line, segment, or ray that is perpendicular to the given segment and passes through its midpoint. And then we had some theorems based on that. The perpendicular bisector theorem is if I have a point on the perpendicular bisector of a segment, so I already know I have that perpendicular bisector, then it's equal distance from the endpoints of the segment. And then the converse is true as well. If I have a point that's equidistant from the segment, then it's on the perpendicular bisector of the segment. We also had, that's associated with that, the circumcenter theorem. The circumcenter occurs when you draw in all of your perpendicular bisectors of the sides of a triangle. And that's called the point of concurrency. The point of concurrency of those, or where they intersect, is the circumcenter. We found that the circumcenter is actually equal distance from the vertices of the triangle. So I'm going to do the examples here and kind of show you what that's about. So we start off and we see that we have a perpendicular segment and that it bisects because we have these congruence markers. So what that means is if I have, this is the perpendicular bisector theorem, if I have a perpendicular bisector of a side, then any point that's on that perpendicular bisector, in this case point F, is equal distance from G and M, or the endpoints of the segment, which means that these two sides have to be congruent. So if FG, we find that FG is equal to FM and what that means is that then FM has to be 2.8. If I can get it to right here. I'm going to try that one more time. Okay, and then on the second problem, it tells us that BD is the perpendicular bisector of AC. So even though we don't see that we have congruent parts, we just see the perpendicular ray going through A and C. It does say it's the bisector, so that means CD is equal to AD. And then we have expressions for those. We know that 5x is equal minus 6 is equal to 3x plus 8. And then we can solve for x there. So I'm going to subtract 3x from both sides, which gives me 2x. And then I'm going to add 6 to both sides, which gives me 14. And so x equals 7 when I divide by 2. And that's what I wanted. I wanted to find x. You kind of have to be careful because sometimes you want x and sometimes you want the length of one of the segments. So what you need to do then is you have the rest of the exercises to complete there. You have to find some missing measurements. The second part of the lesson 5.1 was on angle bisectors. An angle bisector, and I'm not real sure why it repeats this. I think it's just a misprint, but an angle bisector bisects an angle and creates two congruent angles. So the angle bisector theorem, if a point is on the bisector of an angle, then it's equal distance from the sides of the angle. And the converse, if a point is in the interior of the angle and it's equidistant from the sides, then it has to be on the angle bisector. And then we also have the in-center theorem. The in-center occurs when your angle bisectors intersect. You should have 3 of those. So the intersection of the 3 angle bisectors is your in-center. And our in-center theorem tells us that the in-center is equidistant from the sides of the triangle. So in the example, it says MR, ray MR, is the angle bisector of angle NMP. So we know that it bisects the angle, and that means that angle 1 is equal to angle 2. So the measure of angle 1 is equal to the measure of angle 2. And they give us expressions for it. It says that find x if the measure of angle 1 is 5x plus 8 and the measure of angle 2 is 8x plus 16. Again, if I subtract 5x, that gives me 3x on the right, and I'm going to add 16, which gives me 24 on the left. And when I divide by 3, I get x equals 8. So that's my answer there, just using that angle bisector theorem.